Prepare to be inspired for his technical keynote. He is a Google AI Director for Cloud of Engineering. He leads teams applying Google's AI advancements to enhance our customer experience and operations. He also co-founded Google Smart Displays and led teams for Google Assistant and Pixel Smart features.
Morning, everyone. I'm Nicolo. Super happy to be here. And thank you for showing up in such a large number. It's very good. And sorry for the few minutes of delay. I'll try to be quick. We don't have a lot of time. Thank you, Dan, for the introduction. I think you covered, you saved at least a few minutes for me because you covered some of the areas, like Google has been really working very hard on this field. And our offering, especially in Google Cloud, is very peculiar. But first, I wanted to talk a little bit before talking about Google and what we do and showing you maybe some new things that we're doing. I wanted to talk a little bit about AI and the generative AI revolution. Morning, Viola. The first, AI's impact is super big. It's expected to be big. This is not stuff that we say generally. Like PwC believes that it's going to be the value of AI is going to reach almost 10% of the world GDP by 2030. And Gartner believes that Gen AI will be a workforce partner for 90% of companies, almost everyone. And you can see like the number of scientific publications on machine learning just keeps skyrocketing. And this is kind of stopping at 2020. If we go to now, it's probably going to be like, I don't know, up here. Will not fit in the slides. Also, what's going to be super interesting and super new is that this is a list of job categories and how generative AI will transform them. This was compiled by Accenture. You can see how all of these type of works, like, have something that has higher potential for automation, or in the green one is potential for augmentations. And, when you look at this, there are things that are much lower potential for, being disrupted or helped a lot by Gen AI. And when you look at what's at the top, this kind of arrow is not perfect, but what's at the top is like things that are more related to knowledge workers. And does my audio work well?
Yeah, I'm going to just, sorry to interrupt. I'm just going to give you that because I think if you put it back, it's not working that well.
Can you hear me better now? Yeah, for sure. Okay, great. So you can see that the knowledge workers here are just like almost all at the top. And of course, this is not just sorted by knowledge worker amount, right? I guess legal is more knowledge worker than office and administrative support. But you can see that, production, building and grounds cleaning, farming, like they're going to be less affected. So for the first time, when we do automation, we're not replacing things that were simpler, but things that require more human brain. So it's a very interesting revolution. It's also very interesting that we can be super optimistic about it because like these tools are gonna augment what every one of us can do. And what we've seen with our customers, when they start using the AI tools and Gen AI, what happens is that every one of their worker on a particular category, the average worker becomes as good as like the best worker. So you're increasing and making everyone better and more productive. What happened? How did that come to be, like this such massive revolution? And well, from a technical perspective, what happened is that there were all of these problems, computer vision, natural language processing, speech, they were all being addressed in multiple ways. Sure, with ML, like, computer vision, in our teams, there are many people that worked on Google Lens. Like we're using a lot of convolutional neural networks of course, I worked a lot on Google Assistant for a large part of my career at Google, and natural language processing was like, a big part of it. There's translation, there is the way we do speech recognition, there is the way we do, autonomous driving with all of these technologies. What's starting to happen is that, well, everything become transformer models. And so everything is becoming very similar, and multiple problems are being addressed with the same basic technology in a way and at a scale that allow them to tackle much better and much faster than before. One of the biggest differences, one of the biggest breakthrough that happened is that we started doing unsupervised pre-training on all knowledge. So basically you take, because what was happening in AI, in ML, was that you find some examples and you label them, and it's a lot of work. So the intuition was that you take internet content, which is almost infinite content, something like this one, a piece of Wikipedia about Barack Obama, and you remove a few words, right? And then you teach the model, these are the words that are supposed to be in here. And so these are the examples, and then you make the model iterate and iterate until it learns how to fill in the blanks. So what happens is that by filling the blanks, like anyone in elementary school, or me, I'm trying still to learn German, given I live in Switzerland, like you can learn a language. By filling the blanks, you can start learning about the words, like doing cause and effects, right? You can start to understand relationship. Basically, at the end of the day, you learn that exposure to sunlight causes skin cancer, or might cause. Filling the blanks can also teach you how to do code, right? And this is why you see these models are able to do so many things, to have a knowledge about the world, to code, or to, how do you speak like Shakespeare? Because they see so much content and they learn how to fill the blanks in poetry that sounds like Shakespeare. And what about images? The same. They learn how to fill the blanks. And so this approach on massive scale is what has led to the Gen AI revolution. Basically, everything that can be tokenized can be used as input, and then you can get output layers as vectors, and then you can predict what are the next word, or you can predict what is the next token in a video, like Sora, or our video poet, Lumiere, or you can predict how it's going to be the next batch of pixels in an image. It's not just about prediction, but when you have very good prediction that start looking, when, this is prediction, but it starts looking so good that you get a lot more out of it. You get React, which is basically, I guess many of you tried this, but it's a way to prompt these models and ask them to reason and then act. And when acting, they can use tools. And these tools, basically, we have them in Bard, we have them in OpenAI. They're able to go and fetch your emails, your Google Drive folders. Particularly useful for us, we work in enterprise, is like retrieval augmented generation, where basically one of the tools, if you want, is searching on companies' data, on databases of all kinds. There is going to be here, like, representative of the search team that work especially on this type of problem. What's more, there is like, these agents also allow you to look at autonomous systems. So there has been this experiment where you have an agent that is able to develop applications by using multiple agents. One is doing design, one is doing documentation, one is doing texting, and of course, there's agents that do the coding. And out of these approaches, of these examples, just like last week, Cognition Labs introduced Devin, which is the first AI software engineers. Still very bad, luckily for us, but they can really do a lot of things and solve simple problems. And they could do some tasks on Upwork, which is a platform where you can do some jobs, some tasks, and get paid for it. But what do we do at Google? Well, first of all, model innovation. Dan discussed how we got here, all of the work that we've been doing, so I'm not going to go through it again. But like our newer models that we just recently announced, the 1.5 class, and this is just the Gemini Pro. We don't have the Ultra yet, but stay tuned. Is like, a mixture of expert model. For the first time, we have a context size of up to 1 million, and we went to 10 million in research. And the performance of the Pro model is similar to the Ultra one. Actually, on text is even better. Usually people say, okay, but when you have a super large context, what happens with it? This is, in the red dots is GPT-4. As you fill in the context up to their limit of 128K, you see that there is a decay in recall in the needle of a stack. You see that here, when the model is very not super filled, the context, you get very good recall, but then as you see, you can actually see a curve. And with Gemini 1.5 Pro, you see that it's very, very, very stable, up to 1 million. So this gives you insane capabilities with large documents and not just documents. But let's look first at documents. These are not people that work for us. These are just people like we took from Twitter or Reddit. This person, says every other AI has failed at it. They basically took a super complicated game, role-playing game, with 352 pages, and then they asked it to roll up a character, and basically it took it. But there is also multimodal. These are some of the things we tried. You get this massive book, Les Miserables, of 1382 pages, and then you give it a drawing and ask, okay, when does this happen? And the model goes through the entire book and says, like, page 1099, this was the context. Even more, they took a video. And why did we take this super old video from 1924? Because it's mute. A lot of the other models, they look at the audio, translate the audio, and then just look at the text. So this is a mute movie. And we asked them, okay, given this movie, tell me some key information from the piece of paper that is removed from the person's pocket and the time code of that moment. And then it tells you, okay, it happens here, and these are the information that were on the paper, and then you can actually go look, and it's exact. Also, another user prompt is, all right, I'll draw this. Tell me when that happens in the scene. And it finds it. So this model is able to go through an entire movie in one single shot of a prompt and find stuff. So you can see how multimodal we're becoming. And these are all innovations that have happened in the last few months. Everyone is still super hyped for people that are looking at it into Gemini 1.5 Pro. And as I said, there are bigger models yet to come. We're not just doing models. Our research continues to do a lot of things. I think we're short on time, so I'll maybe show just one of this. But one of the things that we've been doing is this dream track experiment with YouTube, where some artist, Charlie Puth is a famous singer, pop singer, and you can basically create small songs, just a prompt, and you select the voice of him or others. Let's see it.
Baby, we've got nothing in common, but I know that I'm what you've been wanting for so long now.
Yeah, that's pretty cool. You can do more things, just transforming beatboxing into a drum loop. So you just you sing something with your mouth, and then it becomes like a real song, super high quality. And we're doing this with like the best artists. There's more. This is something that we just announced last week. Basically, it's still research, of course, but it's a foundational model that watches videos. It learns watching videos and determine a relationship between actions and outcomes. So it watches videos and what you're pressing on video games. And now you can make a drawing and say, okay, this is just a drawing or one single static frame of a video game. Then you just start playing with it and it works. It figures out what things are coming next. And so you can build like simple video games and start jumping around. It's super cool. You can see how learning about the world, images, and understanding actions, which is like the next big thing, starts merging together. Also this, right? It's another thing still happening in video games, where you just tell the model on real video games, go to a tree, pick up the mushroom, and they just understand what to do and navigate the video games. So there is so much research going on, and you can see how these things that are fun and happening in video games can apply to real world scenarios. This is what Dan already presented, so I'll just go super quickly to summarize it. It's our entire stack for Google Cloud. We are the only hyperscaler among all of them that provide the full stack. We have our own infrastructure, our own models, and our own technologies on top of it. And we use all of this to build products with our customers. At the same time, while we believe we have the best offering, especially because you can imagine, you see Apple, right? The way they did chips for their phones and optimized software for it, and over time they get very good performance. It took them years. But you can see how when you're planning the next TPUs and when you're planning how to do the models, over time, these two things help each other, and you squeeze the extra performance that gives you the edge. But at the same time, we're not locking you in. So it's very good, it's very fun to work in cloud because you can pick other models, If you don't like TPUs, you can pick NVIDIA's GPUs, and you can pick everything. You're not locked in at every step of the layers. Two examples of some of the apps we built, and then I'm done. This is unbranded, but we're doing it with all of the major food sellers in the US. So this is basically a system automated for doing drive-through food ordering.
Welcome to Google Coffee. What can I get for you today?
Hey, could I just get a latte and 3 chocolate croissants?
And you can see the order
Can I get you anything else?
shows up here.
Yeah, could I also get an iced coffee with milk and 2 sugars?
Which type do you prefer?
Let me get the coconut.
Sure. Anything else?
Yeah, could I also get a caramel macchiato made with no caramel, add 2 pumps sugar-free vanilla, add 3 pumps mocha sauce, and add some extra caramel drizzle, and add some extra mocha drizzle?
Anything
Perfect.
else?
Actually, no, that's it.
Yeah, I wouldn't have guessed that last one, for sure.
Please pull up to the next window.
These things performs at the level or even slightly better than most humans working at this drive-through, and it is live actually, for example, on Wendy's in some selected store in the US. We're not just doing chatbots. We're always talking about chatbots and bots, etc. But we're also completely changing some apps experiences. So you can see like how everything will have Gen AI infused. Like a super simple example, because I don't have time to go through more complex one, but it's this website that we did for Swiss Airlines, where you can basically get travel inspiration, right? This looks like a website. They had a similar version of it, but now you can write things such as this. We are a family of 3 and we're looking for a beach holiday in Europe for next summer. What are good destinations, blah, blah, blah. And it's not a chatbot, it's a full website. So you can see, is it working? Yes, so it finds stuff for each of these cities, which are related to what you ask. It gives you a description, which is like specific to what you asked. So these are being all LLM generated. You can get more, you load more, and you can get inspired and gives you more stuff. So it gives you a itinerary that is specific to the stuff you asked for. So you want to be in Europe, you want to stay, you want to relax at the beach, you want to have some food, not too complicated, kids friendly. This is all the things you get. And then, of course, hopefully, if you're inspired, you go and buy the flight. So yeah, that was it. What are the challenges for us? It's a journey, not a one-off. The technology is evolving so fast that it's super exciting to work on these things. We are doing it very responsibly. So security, compliance, privacy. We work on some of the most sensitive industries like healthcare, finance, banking, legal, aviation as well. So everyone is asking this. Okay, this is amazing, but it's so expensive to run. How do you ensure you make it faster and cheaper? And then, of course, same thing. How do you make it faster and cheaper? And unlocking disparate data sources. There is like teams that are dedicated to create connectors from everything, unstructured and structured data. So, well, looking forward to hear what everyone else has to present. And thank you, everyone.